Hello everyone, I'm Songmin Lee. Day of this lecture. I want to meet you in the real time, but today is the presidential election day in Korea. So I will proceed as a recorded lecture. From next Wednesday, March 16, we will see you in a real-time lecture. In the advanced hacking practice class, assignments applied with practice will be given after each practice class. In order to proceed with the assignment, please pay attention to the class. After you have listened to the entire class, you can proceed by following the examples on the slide. In your practice environment that you set up last week for the practice process. In the second week practice lecture, we will proceed with genuine privilege programs and experiment variable attack. Let's start with the genuine privilege programs. The table of contents proceeds as follows. Genuity's mechanism and attack surface of genuity program, and the practice of invoking other programs from genuity program will proceed. For the mechanism of genuities, let's compare the time when the genuity bit is applied and when it is not applied. To know what the genuity bit is, you need to understand the difference between the two UIDs. In Linux, there are two types of user ID. First is user ID, real user ID, and the second is effective user ID. Real user ID is the ID of the real owner of the process. Effective user ID is a user ID that is granted while a process is running and is a UID for identifying the privileges of running process. Let's checking how it works is as follows. Copy the program that prints the user ID of the running processor to my ID using the cp command. After that, use the chown command to change each owner to root. And when you run it, you can see the UID is not output. Only the contents of the UID are displayed. The reason the EID is not shown is because EID is omitted when UID and the EID are same. Since the UID bit is not set, even if the owner is root, the EID contains to be the seed, which is the same value as the UID. After that, let's enable the genuid bit using the chmod 4755 command. Then you can see that the value of the EID has been changed to the root. Okay, let's proceed with an exercise using the genuid mechanism. This time, copy the cat command to the my cat. Let's change the owner of the file to root and check if the owner has changed successfully using the ls/l command. Even if the owner of the file is root, if you don't set genuid, you can't get the real root authority. So you can't open the shadow file that only root can open. After setting genuid through chmod 4755, you get root privileges normally. You can check that you can open the shadow file in which the password is written as a hash value. This time, we will practice how to use genuid in code and capability leaking through use. The following number one, the open function to open a file called ZZZ that can modify it only with root privileges and obtain file descriptor. And the following number two, through GNUID, the user or real user ID of the current process is obtained through GNU ID. That is the UID of the seed, and the authority downgraded from root to seed through the GNUID function. And as in number 3, the process of invoking the shell program is carried out, and the shell is opened through the execv function. The reason for lowering the privilege here is to prevent permanently root privileges by making this shell open as a user shell other than the root shell when running. But that code is problem because it omitted closing the file descriptor. The picture on the right shows the process of leaking capability using that problem. While the current file descriptor is maintained, the cap on the slash leak program with GNUID is executed. The arrow and command is a command to write the file to a specific file descriptor. If you modify the ZZZ file by using this file descriptor again through the arrow and with 3 commands, you can see that command the content is modified. Okay, this example is use the system function to obtain a shell with root privileges. This is a program with to use the command bin cat in cat or the slash as the system function and to receive arguments at this time. Remember that the system function receives the command itself as a corresponding argument in the code, and let's execute it. Because our practice environment is Ubuntu 16, before proceeding with the corresponding experiment, you must precede the command in the upper right corner. Bin sh point to bin dash. The dash cell has a mitigation applied to automatically drop privileges if the code UID and EID are different. So in order to attack, you need to set sh to point to zsh, z shell. After the attack is over, you need to point shell to dash again, like the second command. If you pass commands with semicolons as an argument, that is meaning the execution of multiple commands, A, and bin shell will proceed sequentially. Through this, you can finally see how to acquire the root shell. And finally, you can check that the EUID is root through the ID command. The next sample is safe approach. If there is one change compared to the previous example, the file is not executed with the system call function, but the code is composed using the execve function. In this way, the vulnerability can be protected. Because the system function passed the string received as a parameter directly to the shell and executed it, the execve function directly informs the OS which command to execute so that only the intended command can be executed. In detail, when the execve command executes programs, code that is name of command and data are completely separated. Therefore, when receiving an argument, the entire string AA semicolon bin shell is judged as a command and executed, so the code can operate it in a protected state. Okay, next is we will proceed with the second lecture, environment, variable, and attack. Content will proceed as follows. Attack uh, via dynamic linkers and application code. Let's start with an example of my stack and dynamic linkers. As shown in the first picture, let's write a code called hello-c that prints hello world and compiled it with GCC. At this time, if you give GCC the argument slash static and compile it, you can see that the size of the compiled file is about 100 times larger than the compiled without slash static. The reason is that static linking use a method of copying all library modules used in the program during compile. So the size of the compiled binary is large. In the other hand, if you compile without the slash static argument to GCC, dynamic linking is performed by default. Dynamic linking is a method in which all libraries used in the program are not copied during compilation. Only the addresses of the modules are kept, and then the address of the module in the shared library is moved to the address of the shared library at runtime, and the necessary ones are retrieved. So you can see that the file size of the dynamic linking method is smaller than the static linking method. And as shown in the right figure, you can check which shared library the program depends on by using the LDD command. Okay, let's proceed with an example of an attack using the dynamic linker method. You can see the code where a function called strip is used the mytest.c code in the picture on the left. The existing strip function simply does not output anything, and the program ends after resting for 1 second. Now, as shown in the code picture on the left, you can see the strip function we wrote is executed when the code called myTest is executed by writing the code called strip.c and changing the environment variable for these functions. Let's write a program that prints the string I am not stripping. And by giving the /c options when compiling, we will create an object file by compiling without performing linking. And when linking this object file, give the shared option to make it a library file. After that, an environment variable called ld preload is set to the created library file. RT preload is named preload because it is searched first by the dynamic linker. At this time, we set the library we made. So when the program called strip is executed, you can see that the code you made is executed instead of the existing strip function. Oh, sorry. After that, if the preload environment variable is removed through unset preload, the original thread function is linked again. Mm, the examples modifies the path environment variable to obtain the share. Create an executable called first using normal car calendar commands and grant root privilege using ID. Now put a command using the bin bash /p options to change the environment variable uh, forcibly into the system function and save it as car.c. Place the malicious car program, car program in the same directory as the uh, var executable. At this time, add the current path to the path environment variable so that the first directory directory is that um, respond, representing the current folder. After setup, run the privileged program for again. The dot at the beginning of the list um, cause the shell program to look in the current folder first when searching for the her program. So we can't see the calendar program and we get the root share. Okay, the last example is an example to practice vulnerable parts in the system through a function called getinf that can know the location of the current directory at the code level. Let's print the current path through the command pwd. You can see a home seed temp. Then let's check the pwd, which stores the current directory as an environment variable. Let's change the path and check the environment variable pwd again. Print the current directory. And then let's change the value of the pwd environment variable to xyz and see if pwd works. The command pwd works normally. However, you can see that the pwd environment variable is output as the changed value. Let's look at the picture to the right of the problems. That may arise by using this point. The print under slash pwd.c code first declares the ARR array has a size of 200. Use the getinf function in a variable called pti to store the contents of the environment variable called pwd. Getinf is an API that returns the value of the environment variable. Then a pointer pointing to the returned value is stored in the ptr variable. Then using sprintf function, the string value including the value pointed to by the ptr pointer is copied into the AR variable and proceed with printing. It appears that the vulnerability does not exist on the system. However, what if the value of the pwd environment variable becomes larger than the size of the buffer that array can contain? The OS can be recognized as a buffer overflow attack that attacks the system by storing in effects as of the size of buffer. An example like this is shown in lower left picture. If you give the PWD variable as simple as XYZ, you can see that there is no problem by outputting the PWD environment variable through echo. However, if the value of the environment variable PWD exceeds the size of the array uh, AR array, the 200, you will see the abort or segment fault. Okay, this is end of the explanation for the second week of CNUID privilege programs and experiment variable attack classes. Now, you can directly type the practice example in the environment you actually configured and see the result. And after the practice class, an assignment that can be applied to the practice class will be held every week. Open the assignment PDF file provided on the Notion page and solve the tasks and submit them. The tasks of this lecture are 2, 3, 5, 7. The assignment score is given differently depending on whether all tasks have core content written where. First, describe what purpose of the task is for. And in the second, attach a screenshot of the process of solving the task and attach the result of the task solved in the third. And finally, describe the consideration obtained by solving the task in the fourth. There are rules to follow when submitting assignments. Please submit assignments only in PDF file format and submit the file name in the following format. And receive 0 points if you copy the assignment. Submit it in the Blackboard assignment submission box. And the submission deadline is Tuesday, March 5th. You are also accepting delay. We are also accepting delay submissions. Scores are reduced by 10% per day, and submissions made after 10 days will receive 0 points. For all questions related with to the practical class, please send an email to koreacss 2022 gmail.com. Then we will reply as soon as possible. Okay, thank you. We will see you next week.